Good morning, ma'am. This is Harini from 2nd Btech CSC in Srinivasa Ramanjan Institute of Technology, Anantapur. My roll number is 244G580507. Today my topic is recurrence relation. Recurrence relation is an equation that recursively defines a sequence where each term is a function of its preceding terms. Recurrence relations are commonly used to describe sequences that arise in combinatorics, algorithms, and mathematical problem solving. Types of recurrence relations are linear or non-linear recurrence relation, homogeneous and non-homogeneous recurrence relation, order of the recurrence. Solving recurrence relation in 4 methods: iteration method, recursion tree method, master theorem, characteristic equation method. Characteristic equation method means for linear homogeneous recurrence relations with constant coefficients, we can solve them using a characteristic equation. Homogeneous solutions. For homogeneous recurrences, the solution often involves finding the roots of the characteristic equation and forming the general solution based on these roots. The non-homogeneous relation is opposite to the homogeneous relations. Problem. Satisfy the recurrence relation an plus 2 plus b n plus 1 plus c an equals to 0. For n greater than or equals to 0, determine the constants b and c. Then solve the relation for an if a0 equals to 0, a1 equals to 1, a2 equals to 4, a3 equals to 37. This is given problem. The solution means given in that question is an plus 2 plus b into an plus 1 plus c into an equals to 0 for n greater than or equals to 0, and a0 equals to 0, a1 equals to 1, a2 equals to 4 and a3 equals to 37 is given data. We can take in as an plus 2, a into n plus 2 by plus b into an plus 1 plus c into an equals to 0. It is taken as equation 1 for n equals to 0 and n equals to 1. Then that means we can put for n equals to 0 and n equals to 1 in equation 1 after 1. Firstly we can put in 1 equals to 0 in equation 1. That is, after we place the n equals to 0 in first equation, the second equation is coming. That means an plus 2, that means n plus we can replace it as 0. A 0 plus 2 equals to a2 plus b into an plus 1 equals to b into an plus c a0 equals to 0. This is equation 2, and a3 ba2 plus ca1 equals to 0, equation 3. This equation 3 is coming from put n equals to 1. That means an plus 2 equals to a1 plus 2 equals to a3. That's time. Given a2 equals to 4 and a3 equals to 37. We can put this a2 equals to 4 and a3 equals to 37 in. Firstly we taken equals to a2 equals to 4. It is placed in the equation 2. To place it as equation 2 4. a2 equals to 4 plus b into a1 equals to 1, b into a1 equals to 1, b into 1 b, 4 plus b plus c a0 equals to 0. That means c into 0 0. That's why 4 plus b plus 0 equals to 0. That's why 4 plus b equals to 4 minus 1. The value of b equals to minus 4. After that 37 is placed in the equation 3. That's why 37 plus b into a2 value is 4, b into 4 plus c into 1. That's why 37 plus 4 into this minus 4 is b value. Minus 4 plus c equals to 0. 37 minus 16 plus c equals to 0. 4 into 4, 16 plus into minus 16. 13 minus 16 plus c equals to 0. 37 minus 16 plus 27 plus c equals to 0. C equals to 21. C equals to 21. This equation 1, a n plus 2 minus 4 a n plus 1 minus 21. These 4 minus 4 and minus 21 are values of b and c for n greater than or equals to 0. Put n equals to n minus 2. We can replace it as in place we can put is n minus 2. That's after that n minus 2 is put in the equation 1. The values are a n minus 4 a n minus 1 minus 21 a n minus 2 equals to 0. For n minus 2 greater than or equals to 0, that means n greater than or equals to 2. That's why this equation is coming from a into 2 n minus 2 plus 2. Minus 2 plus 2 cancel, a n is remaining. Minus 4 into a n minus 1 plus minus 2 plus 1 minus 2. N plus 1 minus 2 equals to n plus minus 1. That's this equation. This expression is converted into this t square minus 4t minus 21 equals to 0. We can find the roots of this equation t square minus 4t minus 21 equals to 0. Find roots for this equation. The roots are plus 3t and minus 7t. T square plus 3t minus 7t minus 21 equals to 0. How to find the roots are how to get the roots means we can add these two roots, we can get the middle element. T, we can common these elements numbers. T into t plus 3, first two numbers. Minus 7 into t plus 3 equals to 0. T plus 3 into t minus 7 equals to t equals to minus 3, 7. A n, we can replace it. The roots are in the equations. A n equal to c1 into minus 3 into 7. This is the formula. A n equals to c1 alpha n plus c2 alpha n. Alpha 1 n to c2 alpha 2 n 2 power n. Equation 2. Given a naught equals to n. Put n equals to 0 in equation 2. A naught equals to c1 plus c2. 0 equals to c1 plus c2 equation 3. Put n equals to 1 in equation 2. a1 equal to c1 minus 3 c1 plus 7 c2. 1 a1 we can replace it as a1 equals to 1 equal to minus 3 c1 plus 7 c2 is equals to equation 4. We can solve 3 and 4. We can get c equals to minus 1 by 10 and c2 equals to 1 by 10. After last, the solution is an equals to minus 1 by 10 into minus 3 equals to minus 1 by 10 into minus 3 whole power n plus 1 by 10 into 7 power whole power n. Conclusion. Recurrence relations provide a powerful tool in discrete mathematics and graph theory by offering a structured approach to analyze and solve problems based on previous results. Their stories often reveal the asymptotic behavior of sequences, which is essential for algorithm complexity analysis and combinatorial structure explanation. Mastering recurrence relations allows us to tackle recursive algorithms, combinatorial counting, and dynamic programming problems more effectively. Thank you, ma'am.